Again.
The difference among the three files, L2, L5, and L6.
Difference? L2 is at the phylum level.
Okay. And
L5 is family level, and L6 at genus level.
Okay.
And for NGS data, we focus on these three data. Okay, and now here is L6. My laptop is not so strong. Oh, L6 must be very a lot of data. A lot of data. By looking at here, you don't understand anything. And just paste here. Okay, and save. I will label it L6 original. I keep it there, and I will make another 6. L6 original 2, and I copy this into here, and I will modify in this sheet. I did first line, and here you can see it's not in the right order. Q1, Q2, Q3, so we need to reorder it. Move this here. Q3. Q4. Q5. Is Q6, 7, 8, 9. Okay, and 10, 11, 12, 13, 14. You need to confirm the order is correct because this will affect the downstream result. 8, 9. So here they have because I want to compare the sample of this time and last time to see the intervariation. And then Q1, where is Q1B? Here. And Q21 and Q21. So I copy this and put here. And delete this. And it's Q1.
1B.
Yeah. So I delete this. This I delete. Okay. Have like sorted in the right order. And next, what should we do? We will this you can see a lot of genera. Oh, let me see how many. Oh, around 1,200. So we need to filter. It's impossible to filter manually, and I will close this. I will use. I will make analysis 1%. Okay. I need to rename because we don't know what is Q1 this, so we need to replace like Q1 is equal to this sample, and this sample is belong to under before treatment. So I want to use this, so I copy and paste here and make sure it's correct. Okay, it's correct. Then we copy this, and now I will make the criteria range to filter here. Sorry, because I did percentage is very small, and so I want to like I want to show at the, like we can see this is 11.4%. So if so I want to multiply with 100. So if not, so it will become 0.1142. So it's not easy to see. So I want to see easier. So I will convert this into 100 or multiply with this with 100. So I will make another sheet. I will copy this, paste here, and then copy this. Paste here, and this is B2 multiply with 100. Let's see, B2 we did it the beginning. Here is B2. So just multiply this figure
by 100.
Yeah, 100. I should make it easier to see. Okay, so I will do this for all the sample. Okay, this. And how many sample? calculate because when I drag I cannot see.
Yeah.
Oh no, this no need because I still keep it, so I don't need. I will drag. Yeah, okay. Yeah, it's already multiplied with 100. Save. And then what I do now is copy this and paste here. Paste here. And to paste here, so we will use this. If we don't use this, it will also copy the formula. So I'll only paste the figure, so you can see. Okay, it's okay. Now I will copy the criteria. Copy. We start the criteria from here, from the first sample, not from here.
Question. Maybe you can demonstrate. Yesterday you showed me how to set this criteria, but it was Japanese version. So show me how you set criteria here.
How to set criteria? The criteria range is should be separate from the data range. Data, yeah. By one line or two line or more is not a problem, but you should have the separate. And then the title. This title is not correct. This title is not correct. And yeah. Okay, I will make the title again. Title. We need this title, right? Sorry, I copied wrong. We need this title. Yeah. So the title of the data range and the criteria range should be similar. And then that is the criteria. And the criteria here, because I want to filter the sample with have at least one sample higher than 1%. So I set it here. Here is higher than 1. In case you want to filter as 5%, you will change into 5. And use this criteria for another sample. Like this, you just copy and paste, and it's not on the same line, same row, but for the second sample, you can see I go to another line, go to the second line. For third sample, I go to the third line, until you finish your sample. Here you can see the sample is finished here, and this now I don't want to handle with this data. So the filter will stop here until you finish the final sample. And then you already create the criteria range. And next is you will filter your data. To filter your data, put the mouse on the data range and go to the data, advanced filter, this is advanced filter, and this will automatically choose your data range. And for the criteria range, you need to choose by your here. You should choose from here, not at the, yeah. Until it's finished here. Okay, and copy to another location. And also this should be separate from the criteria range. So the criteria range will stop at 1248. So one line space. So I will choose as 1250. Yeah, 1250. Here or here or here or here, it doesn't matter, but I prefer to one line space. Okay, it's finished. Now it is 1% filter, and I will cut or copy, it doesn't matter. Now I want to cut this into here. Yeah, so from 1200 genera is remain 57 genera. And okay, what will we do next? Next I want to, because here you can see kingdom, phylum, see class, order, family, and genus. So it's in one column. It's only in one column. So I want to separate it. I want to only keep the phylum and family and genera. So I need to when I didn't know, I do manually. It takes a lot of time. I need to delete and one by one. But now
So let me ask you, this is L6 file, but it still have family and order.
Because it's only show you how can I say, this genus belong to
which family?
which family, which order, which class, or which phylum. If you don't have this information, you need to go to the Google to search. Methanol, this belong to which family and belong to which phylum. Sensei will soon ask you, and you need to discuss about this when you prepare the paper. So this information is very useful. So how to make it? 1, 2, 3, 4, 5. Now we have from kingdom to genus, we have 6 units. So I want to make 6 columns, and this already have 1 column. So I will make another 5 columns. Blank here, insert. So here, but you can see here is blank. Blank here, blank. Right. So I will convert from text to column. Use this function in data and mesh, and you can see it will be separate by the semicolon. So choose semicolon, then tab, and then click finish. It will automatically now convert phylum to another column, and family and genus to a different column. And then we will label this is phylum. I need to keep phylum, family, and genus. And remaining I will delete. But before, for example, with this I should write this other, and this family is if I delete this information, and you see this, you will not know this belong to which order with phylum. So in this case, I will copy the previous known taxa. So in this case, is order. We know this here, and genus we can label same. For this also, we label. This genus is unknown, so we use this information. This unknown, this information, use previous known that information. Yeah. Sometimes sensei will delete this, but in my case, I want to keep that. If later we need this, we can use. But if we don't need, we can delete. But if we delete now, so later, if we want to, we find some interesting genus or family, but it's unidentified, and so in that case, we need to reanalyze the sample. So if we prepare in advance, so we don't need to reanalyze when we want to discuss the unidentified family or genus. Copy, V, copy, V, no. Wow, fine. Family, genus. I don't get this information, so I don't need.
So this up to phylum level is not identified.
I can see in some paper. They characterize at genus level, but some they cannot. So and they just can detect at the phylum level. In that case, they also say on this unclassified like proteobacteria something. Okay, and I will delete this and column this. And okay. Okay, next what will we do? Summarize the data. Summarize the data. Okay. Like this, I will summarize with its treatment. Here. And to copy the title again here. Copy. Paste here. Okay, the first genus is from here, and then just use the average. From here to here. One, now is three is two, plus, and 4 is 4 plus. And 6 is 2 minus. 6 is 2 minus, yeah. Okay. And finally 7 is 4 minus. Okay. And just do this for similars. Okay. And okay, and I want to label the highlight the high relative abundance as like 5. 5 is high, maybe 1, 2. Some genus which have higher than 2%, they will be highlighted. This just for our visualization. This is like, and from this you can create a graph, like column inserts. Recommended. This. Because at genus level, so many you cannot see clearly. But this figure we sometimes see or use in the paper for the summary.
At the genus level?
At genus or phylum or family level, they also use. They use this or heat map.
When you discuss this kind of data, which level do you really focus on?
Family level. In our lab, Sensei recommend at the family level. But sometimes I see genus level is also interesting. We can discuss deeper. But Sensei don't prefer. Okay, but this is just show you the general overview of your data. And to see the difference, significant difference, you need to use some software for statistical analysis. And okay, another tip. Usually we will not use this letter. We should delete this. You can delete manually like this, but it really takes time. Then we can use the functions like, okay, in this case I will filter in only this column. I choose this column and find, replace this with nothing else. Replace on. So in this case, then we place on in this column. And in a family, I also want to remove, find, replace this. Okay. And you can see if this different letter, so it will remain, and we can know that this is unknown at family level, and it belongs to previous tasa. If you don't choose the column and you choose like this and replace, and it will replace all, and later you cannot recognize, oh, this is in family or at genus level. So by only choose the column, you can avoid that misleading. That's fine. Replace. Okay, so now you have a better data. And what we should do next is statistical analysis.
Before we go to that, when we set criteria over 1%, did you do it manually or there is a function you used? Here, when we set criteria, each column, succeeding column, we use over 1%. Did you do it manually or there is a function you input? Here.
Yeah.
And did you do it manually or?
Yeah, I do it manually. I just copy and paste. But you can copy many. For example, you choose a lot of this, copy, and then you paste here. And then it's very fast.
Okay.
Okay, and next, let's prepare for the statistical analysis. Okay, for statistical analysis, we use this data, just copy and paste here, and we need to convert it into vertical. And we only use the genus, and in the statistical analysis, they only accept one title, so we should delete this. Okay, and make another column, because here they, and in statistical they will group sample together. So in that case we need to relabel. Yeah, I will relabel like this. It's treatment. They have 10 count with 10 repeat. So I paste here. But then here genus, and then check to see if it's correct or not. Okay, 7 with 4. Okay, then we can delete. Save. Yeah, this file is ready for analysis, and you can close some, and then this is this. Okay, and here I have the statistical software. Okay. record, and later I will send you so you know.
Oh, thank you.
I need to take note.
Thank you so much.
First time I use this. Just download 5 minutes before you come.
Thank you so much.
Okay. For to make it simple, maybe I should use the L2 because this step is similar, so maybe better to use L2. It's less and you easier to focus. It's too many. Okay. Yeah, I will do this one. Usually you don't need to change anything here. And then import. Okay, and first I will show you a Turkey analysis. Analyze this y by x, and here, okay, later. Here you can see the blue one. This is numeric data, and the column is like the test, and we will separate that in the data we put in y, and this the treatment. Okay, we put in x, okay. And then here they will show you here is the each phylum, and they will show you the variation, and to see the difference we use compare here, left click here, and then compare means, and choose on pair Turkey HID. here you can see and this this label indicate the difference. If the same label is no different, but different label show significant difference. So in this case 2 minus and 4 plus is different from 0, 2 plus and 4 minus. Okay. And you can do similar for other phylum. And to make it faster, press Control and use this, click here and compare means on pair. So it will automatically do for other phylum. You don't need to do one by one. Previous I don't know. I did a lot of time. Okay. And then I usually will save this result to work, and later we need the SE value. So to see the show the SE value. Let me see. Yeah. No. SE means. So we will use a mean square up here. So we will use this number for SE calculation. So better to save this data. So later, if you need, you just use open the work and find it. Or if you don't save, you need to reanalyze and use this software. So I prefer to save this. To save, just copy all, Control A, copy, and then this is L2 and the key ESG result. Okay, here's L2, just label again. And paste here. Many programs running with the low RAM memory. That's why it takes time. Okay, you already have the data. Just save. And L2. You will make another sheet. So this is L2. Okay. And for that data, you only need this for the summary. You need this data and paste here, and I only need the value. Okay. And this is Turkey. Turkey. Here is SE, and then you this just make it beauty. That is beta carotens. This is okay. Previously used this, and we just find okay, yeah. First is area Giota, and fill in this letter into that table. B A B B A B. Because this is not in correct order, so you need to remember. So I remember from 0 to plus 4 plus 2 minus 4 minus. Other. So B A B B.
This is others.
Other. You can see the name here.
Okay.
Because this name is not changed. If you move to another, it will show you like this. Okay. If you are working with this, see this, it means this belongs to other. B A B B. Okay. B A B B. Actinobacteria. Okay. Where is 0? Okay. I didn't see 0. A B B B. A B B B. Bacteroidetes. B A B B A B B A B. And make sure it's correct.
Yeah.
Or sometimes you need to check again.
If I read the way you are reading, maybe I can be confused. I would just know
One by one?
where is A? If I know 2 weeks plus, 2 weeks, 4 weeks negative, so I would just fill those two and the rest B.
Yes, we will have less mistake.
But if you are experienced, maybe you can cram all.
On is A, you can fill in not significant like this. And okay, and cyano. Wow, this I need to fill in like one by one, because you can see I cannot read AB, A. Okay, this is cyano.
Oh, 0.
AB, A. So AB, A. Okay, one by one. And BC and C. BC, C. Okay. So in this case, no difference. This no difference, but this no difference.
No.
This different. Decrease. Very difficult to explain. And that's Firmicutes. No difference. Firmicutes. No difference. So copy this, paste here. And OD1.
Is it that they have never found a name for firearm?
No.
For this firearm OD1?
This is the name of the firearm.
You want to tell me the whole world does not have any name to give to this firearm?
But I don't know why it's named like this.
Yeah, I also don't know. I am asking. You want to tell me the world does not have a suitable name for this firearm? And the TM7?
Maybe it's like abbreviation of some other author's name. Like Peter, like you can Peter one. And for 0, A, B. Oh, this follow the order. Wow, interesting. A, B, 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 C, C, D. Oh, B, C, C, D, D. Oh, decrease gradually. Decrease. Oh, almost right. And proteobacteria. Okay. No difference. Oh, difference. B, AB, B, AB, and B, A, B, A. TM7. Okay. A, AB. Remaining is B, A, B. And then executors. C, A, B, C, A, B, and A, B, C, A, B, C, final, A, B, A, A, B, A, and remaining is B. Okay, we finish.
Because I have a question. why you emphasize SE, which I don't know what it is, means.
That is standard error.
Oh, and not p-value.
Huh?
Why you emphasized SE and not p-value?
Not P. P. This is the P value.
Yeah.
It shows the P value.
Yeah, I understand that it shows significant difference, but there is no exact p-value. From here, where do we get exact, like this? And this is p-value.
Yeah, this is P value. It's compare each pair. For example, it's compare 2 plus with 2 minus, and this is significant difference. 2 plus with 2 minus, you can see 2 plus with 2 with 4 minus, 4 minus, yeah, the A and B, so significant difference. So in this case, if by looking at here, so we already know the p-value is lower than 0.05. So in this case, we don't need to care about the p-value. If the p-value is higher than 0.05, it is not significant. So we already know using by through this label. And to see the variation of the data, so we use the standard error. And because here so many treatment, if you compare this with this, so this with this, this with this, this with this, and each pair, so you have a lot of pair here, even only 3, so you have 3 pairs, this with this, this with this, and this with this, and each pair you have the not SE, but we use this the also the error or the variation, but I forgot, long time I didn't use that. How can you say that? Before SE we say we use which
could this be, what is the difference between standard error and standard deviation?
SD? Maybe what I tell you is the SD, standard deviation. It means the difference between the two pairs. SD. So SD show you the difference between only two pairs. This with this, this with this, or this with this. So if you have many treatment, so you have to have many SD. This is make your data complicated. You know, only 3. You have 3 SD. But if you increase 4, so you have a lot of one pair, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair, 7 pair, nearly 7 or 8 pair. So you have 7 or 8, but you have a lot more. So a lot. So you can, in this case, you cannot use SD, and you use SE instead, and SE show you the variation within these, all of this, like pool SE. And to understand more, I think better to read more.
I will read.
But that is what I can remember. So it will make our data easier to see, simpler. And how to calculate this? We calculate SE based on MSE, it's mean square of error. And this value we can, I didn't did for Okay, I did this already. Yeah. We find mean square of error. Copy. No. Okay, yeah. We use this the mean square of error. This copy and paste here. Why? Where is low? What happened?
It's because it's copying error.
Okay. After this, I forgot how. Okay. Okay, thank you. And next, yeah. Okay, Latino. There validators. And Kalami there. Cyanobacteria. Prometheus. OD1. Proteobacteria. TM7. Then I give this. And miracle final. Okay. Another that it is SE, and the formula to calculate this is SQRT. This means, how can I say?
Square root.
Square root. Okay, square root of this divided with the total number of sample in each treatment. In this case, I have 10, so divided with 10. So this is the SE value. and I copy this and paste here only value. Okay, that is the acid value, and this is the normal table we prepare. And to see which is have a higher dominant, I use this one with 5. Okay, with green. Okay, so we can easier to see the dominant phylum. From microtest science, proteobacteria, bacteroidetes, cyano, yeah. Tanicutus is increasing. Okay, that is general. Maybe that enough for at this step. Okay, do you have any comment?
Yeah, yesterday you suggested since a Wilcon.
Wilkinson test? Okay, Wilkinson test is for...
Yeah, okay, I know I have to study them. There is T-test, then there is Taki test, and Wilcon
Wilkinson test. T-test, we use T-test in case we want to analyze like only between 2 treatments. For example, you want to compare between this group and this group, you use T-test. Or this group and this group, you use T-test. But in case here you have many groups, so you use Turkey. And for Turkey is for normal distribution data. It means it's distributed normally. And for non-distributed data, usually for chain data, we will use Wilkinson test, because Wilkinson test is can be applied for normal distribution data and abnormal distribution data, both. So okay, now I will show you how to analyze that. Okay. Analyze this one by X on the similar. Choose on Y phylum X. Okay. And click here. Non-parametric test. Yes, we present test. See the median. No, not median. Where is AB? I want to see. Long time I didn't use this. Usually we will see the equivalent plot, see density, compare density, display. No. Where is that? Why is not compare between this treatment? Multiple comparison. I should use multiple comparison. Okay. Close. Analyze. Maybe I should use multiple comparison. Okay. And parameters. But they don't have on pair. So here they compare each pair. So in this case you can see the p-value of each pair, but it didn't show you the A, B, C label. So I feel difficult to make like
the previous table.
Yeah, like this. So previous they also show this and also show the label A, B, C. But in this case, I feel not easy to label. For example, this group with 2 minus with 0 different. So I can label A, B, but this with this is different. So I need to label compare many things. So until now I still don't know how to make this into this simply.
Okay.
So but similar, just use the different functions like here and non-parametric and multiple comparison. We only have this pair. Okay, or maybe I will try with. I didn't try with this before. But, okay, analyze. I don't know this, but this on pair. Also know that label. Different from Turkey.
Okay. Lastly, what about two-way ANOVA?
Two-way ANOVA. Okay. I could use this data also. Two-way we use two-way. No, two-way I cannot use this data. Two-way I use because this only have only one factor here. So if two, you need another factor. So I use. Where is the data? Sorry, I need to find the data. Yeah. Okay, for milk. That's correct. No. In this experiment, we have two factors: farm and season. So in this case, we can use two-way ANOVA.
Maybe that is similar to what I will do, farm and season.
test result. Okay, yeah. Okay, I will make again. First copy. Yeah. Easy. Okay. Insert. This is from the season from 1 from 1 until here. Okay, no, from 1 until here. This is from 1 here, and this is from 2. Copy, copy. Okay, and season. This is November. Copy. And this is July. Copy. Save. So it this have percentage. Okay, I just get the random value. Random value. Just random value. Save. Okay. Cancel. Open again. Picture. Okay. Import. But we don't need this column anymore. Delete. Okay. So now, okay. Analyze for two-way ANOVA. We go into fit model. Analyze fit model. And then choose here. Choose add and cross.
And cross.
Yeah. Just do these two and cross. And then run. Okay. And you can see the effectors here. So if you have compare this phylum, and you can see farm different, seasonal different, and interaction like that. Also, you can see farm, season, and interaction for one of the phylum in the effect test. And in this case, you can use the p-value, copy and paste into there, or you can label at star, 1 star, 2 star, or not significant. And for add here also you can use as E. And is Here you can, in the analysis of variance, you can see mean square of error. So you can use this value and do similar. Just that. Okay,
Hi.
you already know. Turkey and
This,
Dubai.
this is the best weekend.
Yeah.
Now, if I study, it's very easy to relate.
Stop.